All right, shall we start?
Yes, sir.
Yes.
Yes. Okay.
Yes, sir.
Great. Fine. So in our previous classes, we had done one project on how to integrate the DHT11 or DHT22 sensor, um, and push those readings to the cloud, that is ThinkSpeak. Okay. Now we had just pushed this data, and we had visualized it on the graphs upon our computers screens. Okay, so now there's something in addition that you can do apart from visualization. Okay, using ThinkSpeak. Now you can do the same visualization on your mobile phones as well. So you can download this application called as um, Think ThinkView. It's a it's a freely available uh, application that is available in uh, Play Store. So what you can do is you can configure this app to visualize this data on your mobile phone as well. Not only on the computer, but you can visualize it on your phone as well. Now, how do you do that? Let me just share my mobile phone over here. So if you can install this app, you will be able to visualize the entire graphs over here as well. We will be seeing on how do we visualize those things in our second project, that is our current project that we would like to do. Mm, Now I hope most of you um, have downloaded the Python script that I have given you, and I know some of you have done it, and most of you have got the visualization, and you were able to plot temperature and humidity. If like some of you are like Ashi, I think is yet to test out the application. You
Yes,
just have to make a few code changes, and you will also be done. And I think Harshit is still left and needs some help. Don't worry, we'll get it done. We still have um, classes, and we'll try to uh, sort all of these things in the coming days. Like maybe we can spend some extra time tomorrow, and we can figure it out. Okay, so today I'll introduce you to a new project that we would be doing. Okay, and that is the smart trash can. Okay, so it's a trash can is full. Okay, so now this is a beautiful automation that we can think in IoT. Now, as you know, IoT stands for Internet of Things, and one of the use case of Internet of Things is to detect an event and take some action. Okay, now one such good action that we can take is we can implement such thing, and we can notify the concerned authorities that if the trash can is full, if it is half, or it has been recently cleaned or not. Okay, now this is mainly useful when you can implement it in your schools, or at places um, where physical intervention is uh, should be avoided. Okay, so now since we are living in COVID times, and cleanliness is the foremost thing that will have to follow, and it is also advisable that you do not touch any trash cans or uh, stuff with our bare hands, because we never know what is present inside these trash cans, um, and we never know what it can lead to. So let us utilize this project to uh, to make our lives better uh, by alerting the people who can help us remove the trash can. Okay, so it will not only help you, it will also help the society, and it will uh, it it will make our surroundings a better place to live in. Okay, so in order to implement this project, I am going to use a new kind of sensor called as the ultrasound sensor. Okay, now for those of you who would like to see how an ultrasound sensor would look like, you should be able to find a sensor which looks something similar to it. Okay, so you will have two speaker kind of things over here with four pins. So this is
Yes,
the
sir, I found it.
yes, this is the ultrasound sensor.
Yes, sir.
Yes,
So
sir.
I found it.
okay, so keep it handy with you, and also one breadboard, the same breadboard. You can use the same breadboard and your Arduino boards.
Sir, I have a doubt.
Yeah, what's it?
Sir, can the ultrasound sensor detect normal sounds also?
No. This this sensor does not detect sounds.
And
In fact, it just sends a sound wave and
sir,
the sound wave. Yeah.
yeah, sir, I have two ultrasound sensors then.
Okay, you can use
Yes, sir.
anyone.
One in the quad
Okay.
star and in the
You can use
sensor.
anyone.
Yeah, thank you, sir.
I'll tell you what an ultrasound sensor is, and how it is made up of, what it is made up of, and what is the main purpose of an ultrasound sensor. Okay, now uh, let's see what are the components that we would require. We would require one Arduino board.
Sir,
Yeah.
sir, the Python program is not working for me. The one you sent again.
Oh, okay. May I know your name, please?
Advik, sir.
Ajit. Okay.
So when I type the URL, it says keyboard interrupt or something.
Oh, okay. So, Advik, I'll try to connect with you, and
Yeah, okay.
we'll see on how you can resolve this issue. I think some other person also faced a similar issue, and we were able to figure it out. I
Yeah, okay, sir.
Okay.
And also, I just one more doubt. Should I take out the temperature sensor of the breadboard?
Yeah. So,
Yeah,
can
do
you
I
please
like?
repeat? Can you please repeat that question again?
Yeah, do I take off the temperature
Yeah.
sensor
You,
of
you can,
the? Yeah, okay, and
yeah,
all
you
the
can
wires
take.
as well.
Yep. Okay. So we would require one Arduino Uno board, an ultrasound sensor. Okay. And if you can see that the ultrasonic sensor, it has a name called as HC-SR 3304. Okay. Now most of our sensors, um, they have such kind of names associated with them, and that name is called as the part number of the sensor. Okay. Now if you go to any open market, and if you want to purchase any sensor, you will have to specify the part number. Okay. Because there are multiple ultrasonic sensors in the market, and sometimes if you buy uh, a new version, then then it will be a bit difficult for you to use it. Okay, so that is why you will have to know the specific part name associated with every sensor. Okay, even your DHT sensor, it has its own part name, which starts with AMS. If you would have observed, uh, your DHT sensor, its name is AM2302. It would be printed upon your sensor. If even if it is not, then do not worry, because uh, that's the name of the sensor for you. Okay, and you would need a breadboard and a few jumper wires. Okay, now let us see.
Wait, sorry to disturb, sir. How many jumper wires?
4 jumper wires.
Okay, yeah, I'll just take them out.
Okay.
Sir,
Yeah.
in the kit there are two types, sir. One with pins on both sides and one with no pins. So which one should we take?
Uh, the one with pins.
Okay, sir.
Okay, so these are the connections that you will have to make. But excuse me, let's get back to the connections part. But and let's try to understand what the sensor has to offer us, and what is the mechanism of the sensor, how it is working, and how it is useful for us. Okay, and then we'll get back to the slide of making the connections. Okay, so your ultrasonic sensor, it has 4 pins. VCC, the first pin is the VCC, second like last pin is the ground, and the middle pins are
Trigger and
trigger
echo.
and echo. Okay, now
Yeah.
let's see uh, what an ultrasound sensor is and how it works. Now, can you tell me, you all are students of science. You must have studied in your school that the concept of uh, distance and time, right?
Yes,
Yeah.
sir.
What is
Yes, sir.
what is the relationship between speed, distance, and time?
Speed is equal to distance by time.
Yes, speed is distance by
By
time.
time.
Now, what are the units of speed?
Actually, velocity.
Meters per second.
Yeah, so that makes distance, it is measured in meters, and time is measured in seconds. Right. Now, can you do a simple conversion for me? Suppose, say, I have specified distance to be 2.3 kilometers. Okay, I just want you to work out this small piece of math. Okay, it's very simple. I'll help you out. Suppose, say, um, where's the chat window over here? Okay, so here's the chat window. What we'll do is, suppose, say, distance is 2.3 kilometers and time is 25 minutes. Okay, now I want all of you to calculate speed in meters per second.
Sir, 92 meters per second.
Okay, 92 meters per second. Now, how do you do that?
Sir, if we 2,300 kilometers divided by 25 minutes, so that would be 92 meters per second.
And how did you
No,
connect
no,
it?
sir, that's kilometers per minute. For meters per second, would be 958.3 bar meters per second.
So, how we actually do it is,
You divide
yeah,
the first number, the kilometers, by the amount of time, 25 minutes, to get the answer.
yeah. So we have to convert our kilometers into meters. How do I do that? I
2.3
know that 1 kilometer is equal to 1000
meters.
meters. Okay, and like speed is distance by time. So this is the distance. I figured out the distance in meters. Now I have my time in minutes. Okay, so I'll have to convert my minutes into seconds, because 1 minute has 60 seconds. Okay, now distance is in meters, time is in seconds. Now evaluate this one and tell me what is 2.3 into 1000.
So it's 34 lakh 50,000.
What's 25 times 60?
25 times 60. You will get it as 1.533. Yes, that's the correct answer. 1.533 meters per second, because 2.3 into 1000 will be
Yeah, that's what I got.
2300, right? Divided by 25 into 60.
1,500.
Yes, that is 1500. Now these two zeros will be cancelled, which will be equal to 23 by 15. That equals 1.533 meters per second. Okay, so this is quite simple, like evaluating uh, speed in terms of meters per second. Okay, now I might uh, I can express my speed not only in meters per second. I can express my speed in kilometers per hour or miles per hour. Yes, so if you would have noticed your vehicles and there's a odometer upon your vehicles, which practically measures the speed at which you're traveling, and it will show us the speed in kilometers per hour or miles per hour, depending on what demographic location you are at. Okay, so you will have to know how to convert meters per second into kilometers per hour, and vice versa. Okay, now why I am introducing you to the concept of um, measurement of speed is, we will be using this relation in order to measure the uh, distance of an object. Okay, now what an ultrasound or an ultrasonic sensor it can do is, you are observing you can observe two two sets of things, right? So uh, what these are nothing but they are ultrasound speakers. Okay, so one can transmit sound and one can be able to receive the sound. Okay, now we know that sound is a wave. Okay, so when we transmit sound, it travels as a wave. Now, can you tell me uh, other examples of waves? Do you know any?
Yeah, light waves.
Yes, light.
Light
Light has
waves.
light is a wave, and it is also um, particle in nature. It has duality.
Sir, sonic wave.
Yeah, sonic is nothing but sound.
So supersonic wave.
Yes, all these are sound waves. Okay, okay. So we know that sound is a wave. Now, what actually happens is you see two pins on your ultrasonic sensor, right? Called as trigger and echo. Do you all see it?
Yes, sir.
Yes, sir.
Yeah. So trigger is the pin with which you send a sound wave. Okay. When you make this pin high, you will be blasting a wave of sound into air. Okay. Suppose say this is your sender, and when you send a positive signal to your trigger pin from your Arduino board, it will blast a sound wave in forward direction. Okay. Now, if you would have observed uh, a sound, a wave, when it hits an obstacle. Okay,
It bounces back.
yes, when it hits an obstacle, it bounces back. So, can you observe the dotted form of waves over
Yes,
here?
sir.
Yes,
Yes,
sir.
So, these
So
are the
the so the
electrical.
ultrasound sensor will catch those
Yes,
reflected waves.
yes, yes. So, an ultrasound sensor will do two things. One is it can blast a sound wave, and it can receive a sound wave. You see two of the sensors, or like two speakers kind of things, right? So one is to send a sound wave, the other is to receive a sound wave. Okay, now you can
yeah.
change which one you would like to use for sending, and which one you would like to uh, receive. But if you can observe that just below your speaker, it is written as T and R. Okay,
Yes, sir.
just observe below over here. You can observe
Yes,
that
sir.
it is written as T and this is written as R. So
Transmitter and receiver.
this is the transmitter,
Yeah.
this is the receiver. A transmitter will transmit the sound waves, a receiver will receive the sound waves. So this one will transmit and this one will receive. Okay,
So,
now,
so is this the same concept that satellites work on?
no, 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 no. Satellites work on a different concept. Satellites use different communication protocols, and those are mostly not sound waves. They are something else. They are different kinds of electromagnetic waves, pulses that they transmit. Okay, so we see that our ultrasonic sensor is able to transmit as well as receive the sound waves. Okay, now we know that each like when we consider anything as a wave, then it has some physical properties associated with it. Okay, now one such physical property associated with the wave is the speed with which it is traveling. Okay, now when we say light is a wave, it also has a few properties, like light is able to travel with some speed, with some velocity, we say. Similarly, sound is also traveling at a definite speed. Okay, now this speed, it varies with the medium that we are talking about. Okay, now what do we mean by medium is, um, we can say air is one medium, vacuum is one medium. Okay, water is another medium. Okay, now when we consider something like light, do you know uh, at what speed light travels?
Sir, 3 lakh kilometers per second.
Yeah, 3 into 10 power 8.
Yes, sir.
3 into 10 to the power of 8 meters
8,
per
yeah.
second. That is the speed of
Light.
light. Similarly, even sound has a speed. Okay, the speed of sound in air. Okay, the speed of sound in air as a medium is 340 meters per second.
Sir, I heard that in water it is a little bit faster.
Um, uh,
Sir, it's 343 meters, sir.
approximately, some people take it as 340, some people take it as 341, some as 343. It depends upon the area that we are in, because air, when we consider it as a medium, that medium depends upon multiple factors, like your air, it could be damp. If you are in a uh, region which experiences a lot of rainfall. Similarly, if you are in a sunny or a desert area,
Then the
then
sound will be faster.
yeah, because there's no moisture over there. So that is why
I
there are a
can
few,
slow down the sound waves.
yeah. So there are a few variations on the speed of sound depending upon the area that we are located at. So it is safe for us to assume that the speed of sound is around 340 meters per second. Okay. Now, if you consider water as a medium, then the speed of sound.
1450 to 1498.
Mhm. Have you Googled that up?
Yes, sir.
It's okay. So, speed of sound in water is again, sound generally travels faster depending upon the medium which we choose. And yes, speed of sound in water is around 1450 meters per second. Okay, so that is around, say, 5 times faster, if we can safely assume, or 4 times faster than the speed of sound in air. Okay, now we have talked about the speed of sound. Now let us see how this concept of a speed of a sound is useful for us. Okay, now suppose, say, I transmit a sound wave. I blast a sound wave by giving a positive to my trigger upon my ultrasonic sensor. My wave is traveling. It has hit an object. Once it has hit an object, the wave travels back. Now, can you tell me the distance a sound wave uh, is traveling from start to end? Suppose, say, my transmitter is at this position, and the distance of this object is at, suppose, say, uh, I, I name this distance as r. Now, can you tell me the total distance the sound wave would have traveled from transmitter and back to the receiver. If this distance is r, and the same distance will have to be traveled back, right? If it has to reach the receiver back.
Yeah.
So the
So
total
2R?
yes, the total distance would be r plus r. It would be 2r.
2R.
2 hours.
Okay, so great. So we know that the distance that my sound wave is traveling is, let us say, this 2r. Now I know the speed of sound, don't I? It is 340 meters per second. Okay, now I know speed, and I can calculate the time. Now how do I calculate the time is, I will,
Forward wave plus reflected wave.
Speed divided by distance.
yeah, I'll use this relation, but I will also keep a count of my time in Arduino. Okay, so I can use my Arduino to count time as well. Now what I'll do is, I will blast a wave and start my timer, and I will stop my timer at the time I receive something. Okay, so it will evaluate the time. Okay, now I have time with me, I have speed with me. Okay, now what is the uh, total distance that would be traveled? Distance is, so I can evaluate distance as speed into time, right?
Yeah.
Yes, sir.
So
Yes, sir.
You
distance
can.
is speed into time. Okay. Now I have evaluated the uh, distance as 2r. Okay, for a distance 2r to be traveled with a speed of 340 meters per second into, I can I calculated time using my Arduino. Okay, so using this relationship, suppose say I evaluated the time as 5 seconds, and this is 340 meters per second. Using this, I can evaluate the value of r. Okay, r is equals to 340 divided by 10, because this 2, it will go to the denominator's place. So, and sorry, yeah, so 340 into 5 divided by 2, since this 2 will go into the denominator's place. So I can evaluate my distance in this manner. Okay, so by using an ultrasonic sensor, I would be I can be evaluating the distance. Now, what is the advantage of finding a distance between my transmitter and an object is, suppose say I have a dustbin. Now, if I can place this sensor on top of my dustbin, for example, I will show you one example over here. Okay, say this is my dustbin. Okay, this is a bit short, but assume that a normal dustbin would be this long or longer than this, and it would have a cap, something similar to this, right? Now what if I place my sensor over here, and if I close the bin like this? Okay, if I close the bin like this, then my sensor, it would be positioned like this, and it will be able to transmit one sound wave. Okay,
Yeah,
That
but how will
sound
it get
wave,
stuck? Do we like glue it?
yeah, you can glue it,
Oh, okay.
or you can place a double-sided plaster and stick it over there.
Yeah, okay.
Okay, so now what you can do is, when you blast a sound wave and it hits an obstacle, it will reflect back. Suppose say this obstacle is your trash. Okay, assume that this obstacle is your trash. Your wave hit the trash and it reflected back, and this is able to capture that uh, sound wave again. So you have evaluated at what distance the trash is, right? Suppose say you already measure the level of your dustbin. Suppose say it would be some 30 centimeters, and you have calculated that your trash is at 25 is at 5 centimeters away from your sensor, which means 30 minus 25, which means um, 5 centimeters of space is left, and 25 centimeters of garbage is already filled up, which means you can, when you detect something like this, you can alert the concerned people on suppose say you want that person to clear the trash can. You can always alert that person and you can um, fix it out, right? So we can, what we can do is we can use the same thing speak to set some alerts for us. Okay, thing speak is not only restricted to just visualizing the data. You can also use it to trigger some alerts, like you can trigger some email alerts, or you can post it on Twitter, you can send an SMS. So there are multiple capabilities that uh, ThinkSpeak offers us. So we'll try to use one such thing, and we'll try to send an SMS or one email or post it on Twitter and see how our automatic or smart trash can would work. Okay, so in order to do that, we'll have to first code something upon our Arduino. Okay, now the code is like I will implement whatever we have discussed about speed, distance, and time in terms of my Arduino code. Okay, so first I'll have to declare my uh, trigger pin and my echo pin. Okay, so can you please open up your Arduino and do the typing with me?
Yes, sir.
Yes, sir.
Yes, sir.
Fine.
Yes,
Yes,
sir.
sir.
Yes, sir.
Yeah. So I will
Yes.
declare an integer uh, variable called as trig pin and assign it some value of 11. Okay. Now what is trig pin is nothing but it is the trigger pin. Okay. And my echo pin, let me assign it some value called as 12. Okay, now what is 11 and 12 is nothing but the pins in which my trigger and echo will be placed. Okay, now if you can observe uh, over here, I have connected my uh, trig pin to the 11th pin. Okay, trig is pin 11,
Sir, can you
echo.
leave that up so we can also add our boards, set our boards up?
Yes, we'll do the code first and we'll set this up. Thanks.
Oh, okay,
Yes,
thank
sir.
you.
I'll send it to you. Okay, so let us try to finish the code in our in today's class, and we will also set up the sensor, and we'll try to integrate it with our ThinkSpeak tomorrow. Okay, so that is why I have declared my trig pin as 11 and echo pin as 12. Now I'll have to declare a few other variables like the duration. Duration means time. Distance, I'll be measuring it in centimeters. So I am creating a new variable called as cm, and I will also measure my distance in inches. Okay, because you can convert them from one form to other. So what I'll do is I'll declare three variables: duration to measure my time, centimeters to measure my distance, and inches also to measure distance. Okay, once you're done with it, what we can do is we can begin our serial monitor. Okay, and I am beginning it with a baud rate of 9600. Now please note that you will have to write serial.begin with a specified baud rate in order for you to use serial.print or serial.println. If you do not do the step, or if you ignore this step, then your serial.print will not work.
Sir, how much baud rate should it be?
You can choose it as 9600. You can you can have multiple options like 115200, etc. But uh, those high baud rates might not be suitable for your Arduino Uno. They will work, but let us stick to the basic of 9600. Okay, now once I'm done with serial.begin, I'll have to set my pin modes of 11 and 12, like what will be input and what will be output. Now my trigger pin will be output and echo pin will be input. Can you tell me why I am making one as input and one as output?
Sir, because the receiver will give you the input and the transmitter will output the sound, right?
No, no, no.
Okay.
Your so what you should understand is the trigger pin of your ultrasonic sensor is actually the uh, the input that you would be giving, but when you're connecting it to your Arduino, it will act as an you will have to uh, uh, give an output of 5 volts to that pin. So that is why I'm selecting it as an output. For the ultrasonic sensor, it is input, but for Arduino, it is output. So that is why I'm jumbling over here. Okay.
Okay, sir.
Should we save it, sir?
Yes. We still have some code left to do. Like we'll have to do the code of the loop. Okay.
Okay, sir.
Now our setup is done. So I've selected the input and I've selected the output. Now, some of you had doubts that can we use any pin as input, and why I'm selecting the pin as output. So here, if you can see, I am declaring a pin as an input because I'll have to read whatever echo has been done, like whatever I'm receiving, I'll have to receive it as an input. Then only I'll be able to read it. Okay, so that is why I'm declaring one as input, one as output. Okay, now our loop is a bit big because we'll have to implement our logic. But our logic is pretty simple. All I'll have to do is I'll have to um, simply uh, implement the relation between speed, distance, and Okay, so in order for me to do that, what I'll have to do is I'll have to make my uh, trigger pin low for 5 milliseconds. Now my thing is working with an inverted logic. So what I'm doing is first I'm setting my trigger pin low, then I'm giving a delay of 5 milliseconds, then I'm setting it for 5, like I'm setting it for high and giving a delay of 10 milliseconds.
Sir,
Okay, and then I'm turning it back low. Yeah,
but we don't have to write delay microseconds, right? We can just write delay.
yeah, you can write delay, but inside this thing you'll have to specify it as 5,000 instead of 5.
Okay.
I'm just using this example to show you that you can uh, use this function as well. Instead of delay microseconds, you can use delay as well, but inside you will have to specify your delay in terms of uh, the milliseconds. Okay, so instead of that, we will be using a delay in microseconds itself. Now, do you know the difference between milliseconds and microseconds?
No, sir.
Okay,
No,
when
sir.
when you divide a second by 1,000, you will get a millisecond. Okay, but when you divide by when you divide it by 1 crore or 1 million, you will get it as microseconds. Okay, so when you have, let me just write it over here. 1 millisecond is equal to 1 second divided by 1,000. 1 microsecond. 1 microsecond is equal to 1 second divided by
Sir, I can't hear you.
120.
Someone's mic is unmuted.
3 more zeros.
Sir, I can't hear
I
you.
can't hear you.
Okay,
Yeah, now it's better, sir.
Yes, sir.
I think somebody switched
Yeah,
on the mic.
yeah.
Okay, so this is microsecond. 1 second divided by uh, 1 and 6 zeros. But here it is only 1,000. Millisecond is 1 divided by 1,000. Okay. So
Okay.
1 divided by 1, yeah,
No question, sir. Just said okay.
yeah. Okay, fine. So now why I am following such a pattern is my ultrasonic sensor, it will work uh, in a specified manner. I'll draw it for you and I'll show it to you. Just give me a minute. Okay, so let me start my video. And I hope all of you are able to see my diagram over here. Now what I am doing is, for first 5 microseconds, I am giving a low, which means I am giving it 0 volts supply. Okay, I am giving uh, 0 volt supply for the first 5 microseconds, and then for the next 10 microseconds I am giving it a supply of 5 volts. Okay, from low, I'm making it to high and giving a delay of 10 microseconds. For the next 10 microseconds, it will stay high. Then I'm bringing it back to low. Okay, now why I have to do that is, in order to um, energize my transmitter, I will have to give a trigger of just 10 microseconds. Okay, so for 10 microseconds, if I make it on, or if I give it a high, then it will blast a sound wave. That is how this ultrasonic sensor will work. You can give uh, anything above 10 microseconds as well, but just a 10 microseconds blast is enough. Okay, when you just switch it on for 10 microseconds, then it can emit a sound wave. So that is what I am doing over here. For 10 microseconds, I am switching on my my thing, and it will blast one sound wave. Now you can think of something like a gun, or some machine gun that you're holding. Now what the police or the military people, they do is, they hold the gun for some they hold the trigger for some time, and the bullets will be sprayed from the machine gun, right? So the longer they hold, the more uh, bullets that will be spraying. Now if you want to control that machine gun, you will hold that for very less amount of time, right? So that is something similar to what we are doing over here. We do not want to overutilize our sound wave. We do not want to send a sound wave that is more powerful. Like we just want to limit our sound wave. So that is why we are just um, sending it a sound wave for 10 microseconds. You got that point, right? Why we are doing it? Okay, so let me go into and let me quickly type it. Digital, right? You can follow this over here and start typing it. The microseconds. Okay, for now, please use delay microseconds itself and not uh, the regular delay. Let me just copy this same thing and I'll paste it. Okay, for my 5 microseconds, I'll have to keep it low, then high, then for 10, I'll have to low.
Sir, you told that yours is working on reverse way, right? So should we write it as high, low, or
No, mine is working in reverse, but this program is correct.
okay?
Like your, I have
Yeah,
written
okay,
it
sir, I
for
got
your
it.
board itself.
Yeah, thank you, sir.
Okay, then I am changing my pin mode for pen as input. Okay, so I need not do this again because I have already done it over here. Okay, but let me just redo it. Now I'll be using the variable called as duration that I have created. Okay, now if you can observe, these are global variables that I have created. Okay, because I have created them outside my functional blocks. Now I'll measure the duration as pulsion of echo pen to high. Okay, now I'm measuring the duration uh, of my echo pin to turn as high. Okay, which means I'll count the time until which my echo pin or the input is high, which means I'm just counting how much time it has taken to travel. Okay, so now in order to get my distance, what I'll have to do is I'll have to use this conversion formula. Okay, duration by 2. Now you know why I did duration by 2. It is because um, the time that I'm measuring is for both transmitting as well as receiving, right? So that is why I'm dividing it by 2.
Yeah.
And I'm dividing the whole answer by a value of 29.1, or I can simply multiply it with 0.0343. If you can observe, this 0.0343 is nothing but the speed of sound. I told you, right, the speed of sound is, we take it as 340 meters per second, or 343 meters per second. Okay, now if you divide that 340 meters per second uh, by 1, you will get this answer, 29.1. You can try it out, or you can simply multiply it with a factor of 0.0343. Now why I am taking this value as 0.0343 is because I have converted my meters to centimeters. Okay, so for that reason I'll have to use this factor in centimeters. Okay, now in order to get inches, I'll use this formula. Okay, now 1 inch is equal to 12.54 centimeters. So if I can make the math, I will get this formula. Okay, so I will substitute these two formulas, and I will simply print my output upon my computer screens. Okay, now if you want, I will just mail this program to you, and I will also give you the connections. Like, I will share you the connections today. What you can do is you can make the connections, and you can just send that connections that you have made to me. I will verify, and you can simply upload this code, and just uh, you can try out your like open your serial monitor and see the distance what it is printing. Okay, now when you can, I am leaving this as an exercise to you, so that you will get some hands-on experience on how we are doing it. Okay, so I'll stop my class today with this point, and I am sharing this PPT right away. So what I'm expecting you to do is make these connections and upload this code, and uh, just see if you are getting the output. It is something similar to what we have done with DHT. Only thing is that the code is a bit different over here. Okay, in our next class, what we will do is we will write another Python program, and we'll try to take this data, and we'll try to um, send it to ThinkSpeak, and from ThinkSpeak we will write another program so that we can send an SMS. Okay, so I'm stopping this, and I'm sharing my PPT with you all. So just try out. Do not be afraid. Just make the connections, and send those connections to me. I will verify, and you can visualize the output. Okay.
Yeah, sir. Thank you so much for your time.
Thank you, sir.
You're welcome.